hopefully this is gonna work. Okay, hey Mikey. Hopefully I can make my phone work and get you a good video. So anyways, your question was about CH2O and how we determine what the central atom is. So our central atom is going to be the one that's going to have the most bonds, right? Because it's in the middle, it's got to be stuck with everything here. So we have a total of 4 different atoms. We have a C, we have an H, we have another H, and we have another O. So if we look at the H's, we know that they have 1 valence electron each. Right, so this guy has 1 and this guy has 1. They only need 1 more, right? So they can only form 1 bond apiece. Can they be the central atom? Hopefully you're saying no, because we know we are going to have at least 3 bonds because there's 3 things here and one's got to be in the middle. So we're going to have 1 in the middle stuck with 3 things. We've got to decide which one. It can't be the H's. They're going to have to be on the outside because they can only have 1 bond. So we know they can't be our central atom. So we're left with the O and the C. So our oxygen over here has 6 valence electrons. Right? So it's got room for 2 bonds. It can make 2 bonds. Our carbon over here only has 4 valence electrons, so it can form a combination of 4 bonds. The only one that has enough bonds available to be our central atom for this molecule is going to be our carbon. But there's another way, another trick that you can look at the formula for the molecule and know automatically, just like that, what your central atom is going to be. So, using what you know from the periodic table, our least electronegative atom, so the one that is the worst at holding on to its electrons, is going to be our one in the middle, right? Our more electronegative ones are always going to be around the outside. So if we look at where these are at on the periodic table, our oxygen is the most negative and our carbon is the most positive, right? So if we're looking at where it's out on the periodic table, you know, we got our periodic table here. Looks kind of like that, right? As we go from left to right, our electronegativity increases. We get more negative. Our atoms get better at holding their electrons because they've got a more positively charged nucleus. So our carbon is like here, and our oxygen is over here. So our carbon is more to the left, so it's less electronegative. It's going to have more, a more positive charge most of the time. Right? And we can see our chemical formula for this compound is written with our least electronegative one on the left and our most electronegative one on the right. So if you're looking at any kind of chemical formula, more often than not, the one that's written first is your central atom. And the ones that we'll see, that's going to be the case. You can also see it down here with the number of bonds, and I know you probably need a different color for me to show you that. So I'll just erase all this and see. So if we've got our carbon and it has 4 valence electrons versus our oxygen, which has 6, right? Our one that has the ability to make the most bonds are the least number of valence electrons, right? Except for hydrogen. Hydrogen is an exception because it can only have 2 valence electrons. Our one that has the least valence electrons is going to be the one that can make the most bonds. It's going to be the one that's most likely in the middle. Hope this helps.